Okay, today's topic is Cisco UCS Director. The question is, which task is performed using Cisco UCS Director? Option A, monitors microservices. Option B, deploy container orchestration tools. Option C, install certificates on clients and ports. Option D, deploy converged infrastructure. Next, I will show you an example of microservices. Okay, option B, deploy container orchestration tools. Hello everyone, this is 591 Lab, Cisco Certified DevNet Associate. The certification number is 200901. Firstly, let me introduce the 591 Lab. 591 Lab, pronounced as 591 Lab, is a top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience and for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Okay, today's topic is Cisco UCS Director. The question is, which task is performed using Cisco UCS Director? Option A, monitors microservices. Option B, deploy container orchestration tools. Option C, install certificates on clients and ports. Option D, deploy converged infrastructure. For option A, monitor microservices, first let me introduce what is microservice. Imagine you are building a house. Traditionally, you do contrast it as one big unit with every room and function tightly integrated. Need to fix the plumbing? You might have to tear down a wall or two. Want to repaint the living room? Better prepare for disturbing in the entire house. Now think of the different approach, building a house as the collection of modular units, each serving a specific purpose and functioning independently. You have one module for the kitchen, another for the bedroom, and so on. If you need a renovate or repair something, you can focus solely on that particular model without affecting the rest of the house. That's the essence of microservices. Instead of building software as the monolithic entity, where all functionalities are tightly coupled, microservices break down the application into smaller, independent services. Each service, akin to a modular unit in the house analogy, performs a specific function or task. These microservices communicate with each other through well-defined interfaces, typically APIs. This modular approach brings several advantages. Firstly, it enhances agility and scalability. You can update or modify one service without impacting the entire system. Secondly, it enables teams to work autonomously on different services, fostering faster development cycles. Moreover, microservices prompt fault isolation. One service fails, it doesn't necessarily bring down the entire application. Just like the faulty kitchen model in your house doesn't render the bedroom unusable. This fault tolerance enhances the overall reliability and resilience of the system. We can use Docker or other technical to make every service manager solely. However, managing microservices comes with its challenges. Coordinating communication between services, ensuring consistency across distributed systems, and monitoring the health of individual service. However, managing microservices comes with its challenges. Coordinating communication between services, ensuring consistency across distributed systems, and monitoring the health of individual services become critical tasks. But when implemented effectively, microservice architecture offers a flexible, scalable, and resilient way to build and maintain complex software systems. Much like the well-designed modular house stands strong and adaptable to changing needs. Next, I will show you an example of microservices. The architecture looks like this, and we have some local network. And we also have the analysis center in the cloud or remote server or the data center. But the analysis center will be far away from our client or our network. So if we want to monitoring like CPU data, use the analysis center to deploy like Zabbix or other monitoring tools to directly get the data from local network. It will be to more latency, and this will be not effective. So the best way is we will write some application as like agent in local, and our agent will monitoring the each network in the local station, and the monitoring task will be running on every agent. And then we have another analysis center or remote cloud, and this will be a good way to get data from the every agent to the cloud center. And if we get check some like the CPU data, CPU usage, if the CPU usage is over for example 80%, analysis center will send a command like shutdown or reload your service, reload your machine to the agent application. The agent application will send the same command to do it. Okay, if we have the view of microservices, we will see firstly we have different protocol to monitoring, SNMP or gRPC for telemetry. So the analysis center will not matter to support the SNMP or gRPC or other protocol to monitoring. It's none of his business, I think. But the agent will support a different one. This one will support SNMP, and this one will use gRPC, and this one also use SNMP. So the agent application will be useful to and smart and light to running in the local network. Okay, the agent application will have the API, like CMD API, to receive the command from the remote. Also, the analysis center will have the API for CPU data to retrieve data from the agent. But actually, if we use microservices, this monitoring data will be sent from agent application to the analysis center. Okay, I will give you the actual code for this example. Here is the core services, that means the analysis center. Okay, and here we use the requests and Flask to do requests for sending messages to the agent, and use Flask to create APIs or support the HTTP access from the agent. Only one API. This is the CPU data, and the method is post. Okay, in the CPU data function, firstly they will get the data from the JSON and use the and get again. Yeah, I think this is no. Yeah, and use date down get to get the request. Use the CPU usage key to get the value. So next, to check if the value is none, the value is more than 80%. I mean, and they will send messages, send the reboot now command to the agent service, and the API is CMD. So okay, and use this code, the code service, the analysis center will be receive messages, receive the monitoring data frequently, and to check every metrics, and then do the automation command, and send the automation command to the agent. So the agent will receive the command from code service, and then use this API, and the method is post. And then firstly, the same way to get the command value. The command value is this one. Okay, reboot now. And then do something like reboot. And then if there is this empty, this command, do the reboot. Okay, that's I think this is a simple demo for the code service and agent service, the two applications for microservices. So back to our figure. If we have the microservice architecture, yes, and it's no need to worry about, because this one, if this one down, okay, down, and this, I think this will not affect the agent app in local network B and the agent application in local network C, and also the analysis center will work normally. So we don't need to worry about a single filter, and the architecture will be housed in this filter. And then let's back to our option, monitor microservices. If we want to monitor microservices, we will have some tools to choose. First one is Prometheus. Prometheus is an open source monitoring and alerting toolkit, originally built at SoundCloud. It provides a flexible query language from QL to analyze your data, and integrates well with container-sized environments like Kubernetes. Prometheus collects metrics from instrumented applications and stores them for query and visualization. The second one is Grafana. Grafana is often used alongside Prometheus. Grafana is the open source analysis and monitoring solution. It provides the rich set of visualization options and allows you to build customizable dashboard for monitoring various metrics collected by Prometheus or the monitoring systems. The next one is Dynatrace. Dynatrace is a comprehensive monitoring solution that provides a full stack of observability, including APM. APM means application performance monitoring, like this. Infrastructure monitoring also Dynatrace can do, and digital experience monitoring. Okay, it automatically discovers and maps your microservice architecture and provides insights into performance, dependencies, and potential issues. So Dynatrace is focused on application monitoring, I think. Next one, if you use the AWS CloudWatch is hosting. It can be used to hosting your microservices. CloudWatch can be used for monitoring various metrics, logs, and alarms. It provides a centralized dashboard for monitoring AWS resources and applications. So the last tool is the Datadog. Datadog is a monitoring and analysis platforms that offer comprehensive monitoring for cloud-scale applications, including microservices, and it provides real-time visibility into the performance of your service and the infrastructure, along with advanced analysis and alerting capabilities. So back to our question, if we want to monitoring the microservices, at least I think we do not need the Cisco UCS Director. So this option is not right. Okay, option B, deploy container orchestration tools. If we want to deploy the container orchestration, firstly, the question is which tools can be used to deploy this one? The first I imagine is Kubernetes. Kubernetes is one of the most widely adopted container orchestration platforms. It automates the deployment, scaling, and management of container-sized containerized applications. If you want to deploy containers using Kubernetes, here is general overview of the step you will typically follow. First one, set up a Kubernetes cluster. Choose a platform to deploy your Kubernetes cluster, such as on-premise, public cloud provider like AWS, GCP, Azure, or using managed Kubernetes servers like Google's Kubernetes CS Engine, GKE, Amazon Elastic Kubernetes Service, EKS, or Azure Kubernetes Service, AKS. Following the documentation or guide provided by the chosen platform or service to create a Kubernetes cluster. The second step is to install kubectl. Kubectl is a command line tool for interacting with Kubernetes clusters. Install kubectl on your local machine following the instruction provided in the Kubernetes documentation. That will be right. The third step is to create and manage Docker containers. Containerize your application using Docker by creating a Docker file that defines the container image, then build the Docker image locally or using a CI/CD pipeline, and push the Docker image into a container registry like Docker Hub, Google Container Registry. And the next one is to define Kubernetes deployments. Then you will write Kubernetes manifest files, YAML, to define the desired state of your application, including deployment configurations, services, volumes, and any other necessary resources. At minimum, you will typically create a deployment resource to manage the lifecycle of your application's pods. Okay, the next step is to deploy your application. Use kubectl apply command to deploy your application to the Kubernetes cluster. For example, kubectl apply -f deployment done YAML. Then you will want to monitor your application. Monitor your application means monitor the health and performance of your application. Use Kubernetes tools like kubectl, Kubernetes dashboard, or third-party monitoring solutions. As we mentioned, Prometheus. Okay, set up alerts to be notified of any issue or failures. Okay, the next one is scale and manage your application. In this step, you will use Kubernetes features like horizontal port autoscaler, HPA, to automatically scale the number of replies based on CPU or customer metrics. Update your application by modifying the Kubernetes manifest file and reapplying them using kubectl apply. and then just secrets, configurations, and updates using Kubernetes config maps and the secrets. Okay, so the next one is CI/CD. Implement CI/CD pipelines to automate the build, test, and deployment process of your containerized application on Kubernetes. Integrating with tools like Jenkins, GitLab, CI/CD, Argo CD for seamless CI/CD workflows. And then the last step is to design to backup and disaster recovery. Implement backup and disaster recovery strategies for your Kubernetes cluster and applications, including regular backups of persistent data, disaster recovery plans, and testing. So by following these steps, you can effectively deploy and manage your containers using Kubernetes. Make sure to refer to the official Kubernetes documentation and other results for detailed instruction and the best practice. So this is the how should you do when you want to deploy container orchestration with Kubernetes. But I think Cisco UCS Director will not be a good choice for this task. So the option B is not correct. And back to our question, the option C, install certificates on client endpoints. I think sometimes we install certifications, maybe use the group policy objects, that means GPL for Windows environment. And we can also manually installation for Windows or Linux server, and we can also use the MDM solution, that means mobile device management, like Microsoft Linter, VMware Workspace ONE to our mobile devices. And I think the best practice is to use scrapping to as like the Windows PowerShell, Windows Automation, Power Automation, or the Linux Bash or Python to write some code, write some scrapping to install certifications for automation. So I think the Cisco UCS Director is not the correct tool for the certification installation. The deploy converged infrastructure. So let's come into this one. Go Cisco UCS Director. The front page of Cisco UCS Director actually introduce core feature of this product. And here it supports a variety of hypervisors along with Cisco and third-party servers, network storage, converged and hyper-converged infrastructure. Yeah. So the correct answer of this question is D. Thank you all for attending today's class at FileNet Lab. We hope you found the material informative and helpful. Remember, practice is critical to mastering a new skill. So review the course content and keep practicing with FileNet Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day.
新卡了吗？